Welcome back. This is Mrs. Rebright with Advanced Geometry. Today's lesson is on 1.6, Classify Polygons. Tell whether the figure is a polygon and whether it is convex or concave. All right, so how I memorize this is concave has the word cave in it, like it's caving in. So on this 1A, do you guys see how it's caving in here and here? Do you see that? How it's like caving in? Where here, everything's pushing outward. There's nowhere that you could say, oh, it's caving in. Here, we're caving in here, 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 and here. Do you guys kind of see that? Do you see what I'm talking about? Yes? No? All right, so opening your book to 1.6, can somebody read me out loud, pretty loudly, the definition for a polygon? Anybody?
Polygon is a closed plane figure with the following parts. It is formed by 3 or more line segments called sides. Each side intersects exactly 2 points, one at each endpoint, so that no 2 sides with a common endpoint are totally.
So you can't have anything in the inside. See how this one has like a line on the inside? So this is at 3 line segments intersecting. This is not allowed. So this one is not a polygon. How about here? This is a polygon, and it has 1, 2, 3, 4, 5, 6 sides. This is a hexagon, which is a polygon, right? This is convex because it's all pushing outward. This is a convex hexagon. It is a polygon. This, when he read the definition of a polygon, it cannot have curved sides, right? It can only have straight, like, line segments. So this curve right here says, hey, I'm not a polygon. So this one's not a polygon. This one's not a polygon. How about this one? Is this a polygon? Yes, and it's a what? Concave polygon. How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. It's a dodecagon. Are you guys okay with that? So no segments on the inside, no curved sides. It has to be a closed figure. That's why it has to have at least 3 sides, because think about it. If you have 2, you have like a V. It doesn't actually close. So the smallest polygon, or like the least amount of sides of a polygon, would be a triangle. That's why it has to have at least 3. Make sense? And it can't be like this, where it's just open. It has to close. It has to close. That would be a polygon. That wouldn't be. Okay. Classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So I want you guys to actually turn in your textbooks to page 43 and look at the different names of polygons based on number of sides. Before you actually turn there, let's just see what you guys already know. What is a 3-sided polygon? What is it called? Triangle. 4. 4, quadrilateral. It might be a square, it might be a rectangle, it might be a parallelogram. We don't know. It's just a quadrilateral, 4 sides. 5, pentagon. 6, hexagon. Good. 7 is heptagon. Heptagon. 8 is octagon. 9, nonagon. 10, decagon. 11, they don't have in this textbook, but it is a hendecagon. Some textbooks say it. Most don't. They just leave it out. 12, dodecagon. And then everything after that, we just call it n-gon. So if it's like 13, we say 13-gon. If it's 256, we say 256-gon. If it's 86 sides, we say 86-gon. Right? Are there names for all those? Yes, but only nerds know them. Okay? Like you have to basically be a mathematician to know beyond 12, because who really cares? Right? Do you guys care beyond 12? Not really. If it's not tested, right? Like, unless you want to do this for a career other than teaching in this class, because I don't know them beyond 12. I'm not going to tell you what 156-gon is really called, because I don't know. But I'm sure there are people on this planet who do. Just not me. I don't have time for that. All right, so you guys need to be on page 43. And you need to write down the different types of polygons. So we're going to pause the video real quick so that you guys can record the different types of polygons based on number of sides. So take a quick second to do that. All right, so now that you guys had some time to write down all the different types of polygons based on number of sides, we're going to look at these. So on A, we want to classify the polygon by the number of sides first. So how many sides? 1, 2, 3, 4, 5, 6. What is this called? It is a hexagon. Do you guys see these tick marks? What do these tick marks say? Hey dude, I'm equal. All of these side lengths are equal. If the side lengths are equal, it is an equilateral. All right, what do you guys think equiangular means? That all of the angles are equal. So do you guys see these arc marks saying, hey, we're all equal? So this polygon is equilateral and equiangular. Therefore, it is regular. For it to be regular, it must be equilateral and equiangular, okay? It must be equilateral and equiangular to be a regular shape. So right here, this is a regular hexagon. How about this one? 1, 2, 3, 4 sides. 4 sides is a quadrilateral. Is this equilateral? Are all sides equal? No. Equiangular? No. It has these two are the same, these two are the same, but they're not all the same. These are acute, these are obtuse. Definitely not all the same. So it is not regular. It's not regular, it's not equilateral, and it's not equiangular. Okay? Quadrilateral, not equiangular, not equilateral, not regular. What is that? I don't know what that is. All right, so classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So how many sides? 3, 6, 9, 12 sides. This is a what? Dodecagon. This is a dodecagon. Equilateral? Are all sides equal? Yes. So it is equilateral. Is it equiangular? No. Trick question. Look. 90, 90, 270, because it's 360 minus 90. 90, 90, 270. 90, 90, 270. It's 360 minus 90, 270. 90, 90, 270. They are not all equal. It is not equiangular, therefore it is not regular. Let me give you guys a little cheat sheet. If it is concave, if it's concave, it cannot be regular. If it's concave, it cannot be regular. Does that make sense? If it's concave, it cannot be regular. So this is a dodecagon. It is equilateral. It is not equiangular, therefore it is not regular. No, your angles are dealing with your interior angles. They mark the exterior angles just to throw you off. Yeah, all equal angles is referring to interior angles. So equiangular has all interior angles equal. Okay? Good question. Sketch an example of a convex heptagon and an example of a concave heptagon. How many sides does a heptagon have? How many? 7. Good. I thought I heard 6 for a second. 7. So convex, pushing outward. 1, 2, 3, 4, 5, 6. I can't draw. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Sure. As those have to all be straight lines and those connect, right? There you go. And a concave one. All right, well, I'm going to do the same thing. And I'm just going to cave one side in. One, 2, 3, 4, 5, 6, 7. Looks like a Pac-Man. Kind of. Concave, convex. 7 sides each. You don't have to be an artist. Just kind of have to try. Sometimes erase and try again. Let's see what they came up with. All right. right, so they were like convex. There you go. Okay, that was like way easier. They just made it look like a little house. 1, 2, 3, 4, 5. That's 5 sides. They didn't follow directions. They did a convex pentagon, which is so much easier to draw, just saying. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They really did not follow directions. This is your online textbook. They are so fabulous. They did this one as a decagon, not a heptagon. Their listening comprehension skills are sometimes flawed. All right, so moving on. Classify the polygon shown at the right by the number of sides. All right, so how many sides? 4, and 4 sides is a quadrilateral. Explain how you know that the sides of the polygon are congruent. How do you know the sides are congruent? Because they're all labeled as 2, and 2 equals 2, which equals 2, which equals 2. So yes, this is a equilateral quadrilateral, right? And then what about the angles? The angles of the polygon. How do you know that those are congruent? They're all marked with the little red box which says, hey, I'm 90 degrees, right? These are all 90, 90, 90, 90. So they're not arcs, they're boxes which say I'm 90. So more specifically, this thing, all right angles, all equal sides, quadrilateral, it is a square. This is a regular quadrilateral, it is equilateral and equiangular, therefore it's regular, it is a square. A table is shaped like a regular hexagon. The expression shown represent the side lengths of the hexagonal table. Find the length of each side. So it says that this is a regular hexagon. Since it's regular, what do we know? All sides are equal. Set these two equal and solve. So 3x plus 6 equals 4x minus 2, right? Subtract 3x from both sides. 6 equals x minus 2. Add 2 to both sides. 8 equals x. So now that we know that x is 8, 8 times 4, 32 minus 2. This is 30. This one better be 30 also. 8 times 3, 24. 24 plus 6, 30. So we know we're good. Each side length is 30. All right, I want you guys to try this one on your own, so pause the video and give it a try. All right, so the two angles are 8y and 9y minus 15. We know that they were equal because it was a regular shape. So if we just subtract 9y from both sides, we would have negative y, or negative 1y, equals negative 15. Divide by negative 1 on both sides. Y equals 15. Then plug back in. 8 times 15, well 15 times 2 is 30, so 30 times 4, 120 degrees. Do you guys get 120 degrees? Each angle is 120 degrees. Were you guys able to get that? Good. Awesome. Well, that is everything on today's lesson on 1.6, Classifying Polygons. We hope you enjoyed the lesson. Please like and subscribe.